Good morning, Year 11. Hope you're all well. Just thought I'd go through these questions really quickly. The first two are pretty straightforward. The first one is just vector addition. The answer at the back of the book is all correct, so that one's all good. The second one, what is it? What is the net force acting on a book lying on a desk? Well, it's zero, isn't it? If an object is not moving, there's no net force. So, question 3 here. We're just going to be using vector addition again. We're looking for the direction the chew toy is going to move in. So what we're going to do is we're going to find the components of these two, we're going to add them together, and we're going to get a vector that's probably going to head in this direction. Giving these two forces, one's heading this way, one's heading this way, we can probably imagine the chew toy is probably going to head in something like that. All right? So just breaking these two forces down into their vectors, we'll get, what have we got? Rx equals, so this one here is 6 newtons. This one here is 5 newtons. And we know this is an angle of 45 degrees. So Rx, 6 cos 0. So we've got 6 from here. We're using cos to find our x component, and it's 0 as it's lying along this x-axis here. And that will give us 6, which makes sense, plus 5 cos, and then we're going to go with 225. So we've got 5 from here. We're finding our x component, so cos, and 225 because we're going 90 plus 45 there. Okay? And we should get minus 3.536. If we add those together, we'll get 2.464. So really we're just minusing this number from this number. We've got a negative there. All right, finding our y component. What have we got? We've got 6 sine 0, which will give us 0. That makes sense. And we've got 5 sine 225, which will give us negative 3.536. And if we add those together, we're really just minusing minus 3.536 from 0. So we'll get minus 3.536. Cool. So if we were going to draw a little axis down here, these two numbers would give us something that looks like this, our x-axis. It's going to go along here. That's got a value of 2.464. And then our y value is going to go in the negative direction, and it's got 3.536 as its magnitude. So we want to find the direction of this force here, okay? So if we wanted to work out that force, we'd use Pythagoras, but the question isn't asking for it, it's just asking for the direction. So all we have to do is find tan opposite over adjacent. So we're looking for, this angle here. So our opposite's over here, 3.536 over 2.464, which will give us 55.1 degrees. So this value here is 55.1. So you could write that as 55.1 south of east. You could also write that as south 35 degrees east, or 145 degrees. All right? Next one. A team of donkeys pulls a cart of tourists up a 20-degree hill in Greece. If the cart has a mass of 600 grams, so we've got our mass, this is 20 degrees. How much force must be exerted by the donkeys to move up the hill at a steady speed? So we're trying to figure out the force of this here, okay? There's no friction, we're ignoring it. So we're just working out this value here. So we know that normal reaction force acts perpendicular to a surface, weight acts directly downwards, and then if we find the components of this weight, so this and this value, well, this is going to give us our normal reaction force, isn't it? It's the same. And this one here is going to give us our horizontal force. And because we're ignoring friction, we know that that's what we're looking for here, okay? So, what have we got first? We're going to figure out the weight of this object equals mass times gravity. So 600 times 9.8 equals 5880 newtons. So this value here, this force, is 5880 newtons. We want to find out this value here, this one here. So how are we going to do that? Well, if we've got this angle, this one here must be the same. So we know that's 20 degrees there as well. And we're given our hypotenuse, so we can use sine to figure out this guy here, okay? So we're going to get 5880 sine 20 equals 2001 newtons. So that is that force there, and that's the same as that one there, okay? Hope that makes sense. Let me know if you want another example. A 5,000 kilogram truck is parked on a road surface inclined at an angle of 20 degrees to the horizontal. Calculate the component of the truck's weight that is down the slope of the road and perpendicular to the slope of the road. So, exactly the same as last question. We're going to figure out, for A, calculate the component of the truck's weight that is down the slope of the road. So the amount of weight that is heading down there, well, that's just going to be this component here, isn't it? And perpendicular to the slope of the road, that's going to be this one here. All right? So again, this is at a 20-degree angle. It's a horrible colour. 20 degrees. So this angle here must be 20 degrees. And we're given its mass. So given its mass, we can figure out its weight. Which will give us 49,000 newtons. So if we're going to work out A here, we'll work out A in blue. So what are we working out? Down the slope of the road. So this value here, okay? So we're just going to use sine, same as last time. So, yep, so sine. So we're going to go 49000. We've got our hypotenuse, that's it there. Sine 20, that's our angle, which is going to give us 16,759 newtons. So that there is 16,759 newtons, and that's the component of the truck's weight that is heading down the road in that direction. Perpendicular, this one here, we're just going to use our cos rule, aren't we? Where we've got a hypotenuse, we're finding out our adjacent value. So, let's do this in this colour, B. Exactly the same, just using our cos rule. Cos 20 equals 46,045 newtons. That's that one there. All right, last one. In the case of the car in 4.4 sample problem 3, what is the component down the road surface of the normal reaction force, and what is the normal reaction force? Well, this first one's easy. Normal reaction force always works perpendicular to the surface. It's always going upwards, so it's always going to have just one component, isn't it? It's not going to have a component going this way. So it's going to be 0 for A. What is the normal reaction force? Well, the normal reaction force is going to be, this is our normal reaction force, it's going to be the same as this one, isn't it? So remember, if we had an object sitting somewhere flat, it's got its normal reaction force, the weight in this situation is the same as the normal reaction force. Because this is on a slope, this value here is going to be the same as our normal reaction force. Okay? So what were we given in that question? We were given the mass of the car, which was 1600, so we can work out the weight. Equals 15,680 newtons. So this here is going to be 15,680. Now, we want to work out this one here. So using our cos rule, our adjacent over our hypotenuse, we can go 15,680 cos 15 equals 15,146. Okay, so this value here is 15,146, and because our normal reaction force is the same as this, it's going to be the same as that. Okay, hope that makes sense. Let me know if it doesn't.